So the standard state, or is the state of a material that's defined by a set of conditions. First, it's if it's a pure gas, it's exactly 1 atmosphere of pressure. And again, that's we'll learn a lot more about behavior of gases later. If it's a pure solid or liquid, in its most stable form, and so some things have different forms as solids or liquids, right? Like our carbon example, it could be a diamond or it could be graphite, and it's at exactly 1 atmosphere of pressure and temperature of interest. So that's usually 25 degrees Celsius. And a solution would have a concentration of 1 molar. So these are kind of the way that we define a standard state when we're talking about chemistry, materials, or reactions. So for a standard enthalpy change, we're going to write that as a change in enthalpy with this little degree symbol right there. And that's going to indicate that we're talking about a standard enthalpy change or enthalpy change in a standard state. And so, and this is occurring when all of the reactions and the products are all at their standard state, not just one, but all of them. And so we also have another term, the standard enthalpy of formation right here, which is the same designation, except there is also this subscript F included in it. And it's going to be the enthalpy change for a reaction for forming exactly 1 mole of a pure compound from its constituent elements. And so for this one, you have your pure compound and 1 mole of it as the product, and your reactants are whatever you need to make element-wise to make that compound. And so the elements will have to be in their standard state, and the standard enthalpy of formation for a pure element in its standard state will always be 0 kilojoules per mole. So let's look at an example of calculating an enthalpy of a reaction from a standard enthalpy of reaction. And these are values that are easy to look up in tables in the back of your textbook or in other chemistry reference materials. We're going to look at carbon solid graphite becoming carbon diamond. So we are looking at enthalpies of reaction that we're going to combine. And these are in their standard state. And you know that because of that little degree after the H in the enthalpy. And so we're looking at carbon graphite plus oxygen forming carbon dioxide, or the combustion of graphite. And we're looking at the combustion of diamond. And they have similar but different enthalpies of the reaction. And we're going to use these to have our, carbon graphite on one end right here. And then we'll have our product carbon diamond. So when I look at these, I need to manipulate the second reaction. So my coefficients all look fine. They're all 1. But I need to flip the diamond one so that way it is a product for diamond rather than a reactant. So that means I'm going to take that enthalpy of the reaction and multiply it by -1. And so that's going to look like this right here. So I flip it, and then I multiply that enthalpy of reaction by -1. So I'm going to end up with a positive 396. Now I take the sum of these, I add these up, which means I take everything on my reactant side. Oh, sorry. Sorry again that I'm so sniffly. And add that up, and everything on my product side, and add that up into one expression, one chemical equation. And then I cancel out anything that's the same on either side. And I have oxygen on both sides, and I have 1 carbon dioxide on either side. So those cancel away. And so now I have the reaction that I started with that I was interested in. And I can now take the sum of my manipulated enthalpies. So it's that -934 plus the 396 to give us a 2 kilojoule enthalpy, standard enthalpy for that reaction of graphite converting into diamond.